The diagram below shows the cross-section of a culvert, 6.2 meters wide and 3 meters high with a semicircular opening of diameter 5.6 meters. Calculate using pi is equal to 22/7 where necessary, the perimeter of this cross-section. And so the perimeter of this cross-section is going to be given by this particular expression. Now, how did we get this? Well, the first thing is the perimeter is the distance around the shape. All right, that's the perimeter, distance around the shape. And so notice that this is 3 meters. So we account for this one right there. This is 3 meters, right? So that's why we have 3 meters right here. Also that this is 6.2 meters. So that's why we have 6.2 meters right here. And notice that we have 3 meters right here, because if this side is 3 meters, then this side must also be 3 meters as well. So this is 3 meters. So that's why we have 3 meters here. Now, notice that we have pi r. Now, what is the pi r for? The pi r is to represent this particular distance, right? Because the distance of a semicircle, the distance of the curved portion of a semicircle is given by the formula pi r. And so that's why we have this right here, because that we're accounting for the distance of the curved portion of a semicircle. Okay, so now we have this particular thing here. Now why do we have this expression, right? What does this mean? Okay, so we have to account for this particular section in red, this particular section right there. And like, how are we gonna get that, right? And we also have to account for this particular section as well. All right, these two little red sections, right? Now, what do we know? Well, one thing we do know is that, let me just take this right here. One thing we do know is that, let me use different color. Let's say use green. One thing we do know is that this entire distance, right? This entire distance from here all the way to here, this entire distance, let me use a better, let me draw a better line than that. What we do know is that this entire distance from here all the way to here, right? This entire distance, right? This entire distance from here, right? All the way to here is what? 6.2 meters, right? That's this entire distance, right? That's 6.2 meters, right? So the distance from this end all the way to this end is 6.2. And we know that because this right here is 6.2. So at the bottom here is also going to be 6.2, all right? Now, what else do we know? Well, we know that the distance from here to here is 5.6, all right? And so what we have to do is we're going to subtract 6.2 and 5.6. And that's why we have on top 6.2 minus 5.6, all right? So we have 6.2 minus 5.6, all right? Now, when we have 6.2 minus 5.6, what is that going to leave off? That's going to leave off this red portion right there, right? So that's going to leave off these red portions right there. So if we say 6.2 minus 5.6, the portion that is left over is going to be this red portion and this red portion, right? But we just want to figure out what is the length, the distance of this one by itself. And so we have to divide it by 2 because it's 2 of them. And so that's why we have 6.2 minus 5.6. So we have 6.2 minus 5.6, right? And that's going to give us the red portions. But we want to account for this red portion individually. And so we divide it by 2 because when we divide it by 2, we get this particular distance by itself and we get this particular distance by itself. And so we have 6.2 minus 5.6 divided by 2, right? Which is this distance. And we do it again, 6.2 minus 5.6 divided by 2, which is this red portion right here. And so that means that this particular expression right here accounts for this red portion, and this particular expression right here accounts for this red portion. And so that's what we have, all right? And so we have that this, let me use this color. So we have that this is accounted for, all right? And we have that this is also accounted for, all right? Okay, so now what we have to do now is we have to compute, right? So we have pi r, all right? This is pi r. Now, what is pi r? Well, pi is 22/7 based on this question. Let me erase all ink. So pi is 22/7. That's what pi is. What is r though? What is r? Well, r is the radius, right? The r is the radius of this. R is the radius of this semicircle. We know that the diameter of this semicircle is 5.6. So if we want the radius, well, the radius is going to be equal to the diameter, which is 5.6, right? Divided by 2, okay? And 5.6 divided by 2 is going to be equal to 2.8. So the radius here is 2.8, and that's how we got 2.8 here. And so what we have is we have 22/7 multiplied by r, which is 2.8, okay? And so, and what we have here, we have 6.2 minus 5.6. And when we divide it by 2, we get 0.3. And we get 6.2 minus 5.6. When we divide it by 2, we get 0.3. And it makes sense because this distance is 0.3 and this distance is 0.3. Of course, they should be equal, right? And so we have 3 meters, 6.2 plus 3 meters, 22/7 times 2.8 plus 0.3 meters plus 0.3 meters. Okay, so what do we have when we combine them? Well, we have 22/7, we multiply that by 2.8, and we get 8.8. What we really did was we multiplied 22 by 2.8, and we divide that product by 7, and we get 8.8 meters, and so that's what we have here. And we have 3 meters, 6.2 meters, 3 meters, 8.8 meters, 0.3 meters, and 0.3 meters. So we add all these together. We add all these together, we get 21.6 meters. And 21.6 meters is the perimeter of this cross section. Okay, next, we need to determine the area of the cross section. All right, so in order for us to determine the area of the cross section, this is what we're gonna do. We are going to first figure out the area of this rectangle, right? Because this is a rectangle. So we're gonna figure out the area of this rectangle, right? So we're gonna figure out this area, right? The area of the entire rectangle. That's what we're gonna do first, right? And then we're gonna figure out, okay, what is the area of this semicircle, right? The area of the semicircular portion, right? So we're gonna figure out, okay, what is the area of this semicircular portion? And once we figure out this area, we're going to remove it or take it away from the total area of this rectangle. So we're gonna subtract it from the area of this rectangle. And what would that leave us? Well, that leave us with just the area of the cross section, or the area of the cross section of the culvert. So that'll just leave us with this particular portion, which is the area of the cross section. Once we pull out the area of this semicircle, okay? Okay, so that's what we're gonna do. So first, let's determine the area of the rectangle. It's going to be length times width. The length in this case is 6.2 meters. The width is 3 meters. And so when we multiply them, we get 18.6 meters squared. That's the area of the rectangle. Next, we have to figure out the area of the cross section. I'm sorry, we have to figure out the area of the semicircle. Now, the area of a semicircle is going to be pi r squared divided by 2. That's the area of a semicircle. It's the area of a circle divided by 2. Now, what is r? We said that r is 5.6 divided by 2, which is 2.8. So r in this case is 2.8. So we have 22/7, which is pi, multiplied by a half, because we're accounting for the 2 in the denominator. So you have 22/7 multiplied by a half, multiplied by r squared. So this is r squared, right? The radius is 2.8 squared. Now, what is 22/7? And 22/7, well, what do we do here? What I actually did was I multiplied 22 times 1. And 22 times 1 is going to be 22. And I did 7 times 2, which is 14. And I just kept the 2.8 squared. Next, we have 2.8 squared. That gives us 7.84. And so what we have here is we take 7.84 and we multiply it by 22. Again, we take 7.84 and we multiply it by 22 and we get 172.48. And we have to divide that by 14. When we divide it by 14, we get 12.32 meters squared. Now, in order to figure out the area of the cross section, we have to subtract. We take the area of the rectangle and we subtract it with the area of the semicircle. And when we subtract them, we get 6.28 meters squared. So the area of this cross section is 6.28 meters squared.